the old Bohr-Rutherford model in physical science. And so you may even remember things like this energy level can hold this number of electrons. So first energy level can hold, 2 electrons. Second can hold how many? Second main energy level? Second main energy level? 8. 8. Now, you know what? Here's the thing. I always had a devil of a time remembering that. 2, 8, 18, 32. It seems kind of random. And I would get confused because there's an 8 and a 2, and that's 10, and then there's an 8 and a 10, and that's 18, and is it 18? And I get all confused. I had a horrible time with that. I like the quantum model much better because, number one, we have those nice predictable formulas. So let's do a quick comparison of what we know and what we can say about the Bohr-Rutherford and the new quantum model. So under the old Bohr-Rutherford model, you know that first main energy level holds how many electrons? 2. That's the information we have. That's all the information we have. In the new quantum model, what do we know about that first main energy level?
2 electrons.
We know it's got 2 electrons, but we know more than that.
There's the s orbital.
We know that there's an s orbital. That s orbital has 1 electron spinning up, 1 electron designated as spin down. So we still know it's got 2 electrons, but we've got a lot more detail. The old Bohr-Rutherford model, how many electrons can the second energy level hold?
8.
8. So that's what we know. 8 electrons. What do we know in the new quantum model? We have an s orbital. We've got some of these p orbitals. They each have 2 electrons. 1 spinning up, 1 spinning down. That's a lot more detail. We have the third main energy level. Under the Bohr-Rutherford model, what do we know?
18 electrons.
18 electrons. And that's all we know. And it always felt to me like there should be some pattern here, but I could never see a pattern. When we break it down into the details, I think the patterns are a lot more apparent.
I see the pattern now.
Well, it's real clear here. You can see it here, but you have to look a lot harder. So let's look at the third level. What do we know in the quantum model? SPD, 135, 2 electrons each. So S, P, D, and 2 electrons each. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. It's a whole lot more information. Now, do you remember a concept about something about valence electrons? Does that ring a bell? Okay. What do you know about valence electrons so far? What do you remember?
They're on the outermost energy level.
Outermost energy level. Okay, good. That's exactly what I was hoping somebody would say. They are on the outermost energy level. We also call energy level shells, right? Well, because the quantum model gives us a lot more detail, we can now start to talk not only about shells, but about subshells. So that's a subshell, that's a subshell, that's a subshell, that's a subshell, there's a subshell, there's a subshell. So those subshells are all of the orbitals of the same shape on the same energy level. So what you learned in physical science, and this was correct at the level of understanding that you were doing then, where those valence electrons were on the outermost main energy level, and that's true. But to be more specific, they're actually in the outermost subshell. And we're going to talk a whole lot about valence electrons. By the time we get done with you, you're going to know more about them than you ever thought possible. So this would be called the what subshell? That's the 2s subshell. This is the what subshell? 3d. This is the what subshell? 1s. Here's the 3p subshell. Yeah. Okay. Up on the fourth main energy level, what did we know under the old model? 32 electrons. Not all that exciting. Under the new one, what are all the things we know? We've got an S. We've got our P's. Oh, please don't make me draw the D's again. Please, really? Do I really have to draw the D's again? Really? I hate drawing the D's. I know. It's even worse because you have to draw the F's.
At least those are just random squiggles.
And we know that there are 2 electrons here, 2 electrons there, potentially. Okay, so we know that this is what subshell? 4D subshell. 4S. There's the 4P. So the quantum model, really, it gives us a lot more information, a lot more detail about where these electrons live, about how we can address and speak about them. So let me ask you this, and this is something we haven't really covered yet. It leads up to something we'll do tomorrow. Which electron would you expect to have more energy? One in the 2p subshell, or one in the 7 or 4d subshell?
4D.
4d, yeah. As we move up through the energy levels, they have higher energy. And we're going to talk a whole lot about subshell filling and all that. Yes?
If they're in do they have the same energy level, like if they're in P? Like
Yes.
No matter if they're 2 or 4?
No. No. So 1s is the lowest energy level. Then 2s is higher than 1s. 2p is higher than 2s. 3s is higher than 2p.
Okay.
And we're gonna do what's called the subshell filling diagram tomorrow, and you'll have a map of the exact order of energy for all the subshells that we talk about. Okay, we're gonna stop the video for this.